The 5 most important parameters to consider during metal forming simulations. Metal forming simulation technology is still a very new tool to many. Because of this, it may be hard to take the plunge when hiring these services or looking to buy simulation software. Some may be worried that simulations are not 100% accurate, leaving them with tooling projects with problems. Simulation detects any potential problems such as wrinkles or splits in the material as well as the end strength and material thinning results. Simulation technology can also calculate and compensate for spring back, as well as accurately calculate complex trim and blank developments through multiple forming operations. Incremental forming simulation technology, such as AutoForm, always considers the complete 3D geometry of each forming stage and simulates every increment of the forming process. The mechanical properties of the sheet metal material being simulated are of extreme importance, and are used in the simulation directly. The stress and strain are calculated at a finite number of points on the sheet using the finite element method. Stamping simulation uses AutoForm incremental sheet metal forming simulation software to perform advanced simulation analysis for all sheet metal forming processes, and considers the 5 most important parameters to be as follows. 1. Mechanical properties of the sheet. No simulation is accurate without confirmation of the mechanical properties of the sheet metal being formed. Stamping simulation provides a fast and inexpensive testing service to correctly test and capture stress-strain data for any sheet metal material, to be used in simulation. Without this test, simulation has no basis for accuracy, and therefore cannot be considered reliable. 2. Tooling geometry used in simulation must match tooling manufactured, exactly. A 3D tool design simulated and validated in simulation, must be continued without change to the tool room floor. Any changes to the tooling process steps or shapes must be revalidated in simulation to avoid an unexpected outcome in reality. For this reason, stamping simulation provides final validation for every job. No tooling component should be machined until their final revision level is validated in simulation. A developed blank shape, or trim profile, must also match that used in simulation, to expect the same result in reality. 3. Tooling forces calculated in simulation, must be available in the chosen press equipment. All tooling forces, including total ram force, binder forces, pad forces, draw bead hold down forces are accurately calculated in simulation. If tooling in the real world is placed in a press with less than required tonnage, or if peak forces occur at the derated tonnage cycle of the press, then results found in simulation cannot be achieved in reality. Furthermore, binder forces that use gas cylinders or other spring systems, must closely match those found in simulation, in order to achieve the same result in reality. 4. Tooling clearances. Deep draws with vertical walls, for example, cups, require special attention to clearances. Whilst many simple tools can be machine size for size with little or no clearance, deep draws, especially with vertical walls, cannot. Simulation uses perfect tooling and will show exactly where thickening will occur. However, tooling clearances must be added by the tool maker to correctly allow material to flow, that is, avoid locking up, during a complex deep draw or similar parts. For very high-strength materials, such as stainless steel, clearances may need to be as much as 30% of material thickness. 5. Lubrication of tooling surfaces. Simulation factors in the exact friction values of all tooling faces. A simulation that uses artificially low friction values may make a part successfully in the virtual world but may never be replicated in reality. Stamping simulation uses reasonable friction values for all tooling, and only applies special friction values or lubrication if the same can be achieved in reality. In some cases, high friction values, or a rough finish, may be required to achieve a successful forming outcome.